All right, welcome back. So we're going to continue to go talk about unit circle. Now, one of the one of the hard thing, or one of the thing that most people find it hard is because they do not understand unit circle. Because, well, first it's quite alien to them. All right, what is a unit circle? What does it mean? What is it trying to tell us? What can I find out of it? Um, what what Unicircle is trying to teach you, or what Unicircle is about, is to find the exact value, all right, to find the exact value and of certain angle, all right, and to explore the symmetric characteristic of a circle. All right, we're going to go into those two parts. Well, let's find the angle. All right. So let's just say, let's just use this particular angle here. We will have a so at this particular point here, we will have an x value, right, and a y value. Yeah, correct. And when these two meet, it will form a right angle triangle. Yeah, right. And once we got a right angle triangle, great. We can use sine, tan, and cosine, all right, to find out what the angle is. Correct. So let's say I want to find out this particular angle. Let's just call it theta. Right? And I want to find out using theta. I want to find an expression, all right, for the opposite, which is the red dots, the red line, red dot line, and an expression for the adjacent, which is the blue dot line, with respect to this particular angle. All right. Now we know that from the previous video, well, from your previous learning. Sine theta is equal to opposite over adjacent. Correct? So referring to this particular angle, which is an opposite. The opposite is our red dot line, right? And let's just call that, and remember that is this point, the point here, that red dot line is the y value of that point. Correct? Yeah, think about it. Take a while to think about it. Yeah, the opposite, the opposite side to with respect to the angle is just the y value, or the height of, it's just the height in that line. That height of that line is just the y coordinate, which is literally here. Right? It's just a coordinate here, a height, a y value here. So we know that sine theta is equal to opposite. Oh, sorry, no, not opposite over adjacent here. Oh my god, embarrassing. Opposite over hypotenuse. My bad. All right, so here, that actually becomes y over hypotenuse. I used that one, over hypotenuse. And now this amazing thing you realize in a unit circle is our radius is 1, right? Therefore, our hypotenuse, which is this particular line here, is 1, has a value of 1, right? Because the radius of the circle is 1. So that line from the origin to the outermost of the circle must be the radius of the circle, and hence it's 1. So the hypotenuse is 1 in this case. So that is just equal to sine theta equal to y over 1. Now anything over 1 is itself, right? It doesn't change. Just like it's multiplied by 1 or divided by 1, it doesn't change the value. So therefore, well, I have to wrap this up a bit. So therefore, sine theta is equal to y. Yeah? So sine theta is equal to y. So what that means is very important. So whenever we're looking for sine of a particular angle in a unit circle or in any circle, all right, we are literally looking at the y value. Okay, let me repeat that. When we are looking for sine theta, all right, sine of a particular angle, we are literally looking for the y value on the Cartesian plane of that particular point. Correct? Yeah? You feeling it? Okay, so let's just do one more. Let's go cos theta. Now cos theta is equal to adjacent over hypotenuse. I'm not gonna make a mistake again. Okay? Now, adjacent with respect to this particular angle is actually the x-axis, the x-coordinate of the point here, right? It's literally the x-coordinate of the point here, of the point here. So, therefore, cos theta is equal to x over hypotenuse. And like we talked about before, hypotenuse is literally 1. Right? It's just x over 1. And there you go. Therefore, cos theta is equal to x. So cos of any angle gives you the x-coordinate on the Cartesian plane. Okay? Yeah? Alright, letting it sink in. Yeah? Taking a minute. Don't worry, take a bit for it to sink in. And we know that tan theta, get another expression or a trick identity, we tell us that tan theta is actually equal to sine theta over cos theta. Correct? And now we found an expression for sine theta, which is y, and we found an expression for cos theta, which is just x. So therefore, tan theta is just y over x. Right? It's just y over x. That's tan. And which also makes sense because that's what tangent is. Alright? That's what a tangent is. Okay, so hopefully this part is not too difficult. Alright, once we get that. So with what we have just discovered in mind, we can find some angles valued, so some angles exact values. Alright, so let's go down here. Let's make the two angle. Let's make one side equal to theta, and the other side is degree, not theta, degree, and the other is radian. Right. So we know a certain with what we just discovered, sine theta is actually equal to the y coordinate and cos theta is actually equal to the x coordinate. We can we can come up with some very easy patterns or method to calculate certain angles. So let's just say as 0. Alright, I usually use blue pen. At 0 degree, right at the beginning. Oops, I can't draw zeros. At 0 degree, right at the beginning, right? Well, the radian would be 0 as well, right? Because 0 times, what's it called? 0 times pi over 180 is still 0. Alright, so at 0 degree or 0 radian, what would be sine and cosine and tan equal to? Alright, so let's have a look. So at sine 0, sine represents the y value. Remember, sine represents the y value. So 0, where do we start? Alright, we talked about it last time. Where do we start counting angles in a unit circle? We start counting at the 3 o'clock position. Yeah? So if we start there, that means when the angle 0 is, we're talking about this particular extremity, we're talking about this particular point, right? Here. And here we have 2 coordinates. We have a point, and the point has 2 different coordinates. And 1 as the x coordinate and 0 as the y coordinate. And since we discovered sine theta, sine 0 is equal to, well, theta is just at any angle, right? So sine theta is equal to the y coordinate of that particular point. The y coordinate of this particular point will be 0, right? So therefore, sine 0 will be, oh, I should go like that. So sine 0 would give you, I'll put value here. Value here. So sine 0 would be 0. Right? Because that's what the y value is at that point. Alright? Let's start to see the pattern. Alright, what about cos 0 then? Cos. Alright, 0 degree, 0 radian. And let's look at the beginning. At that point, and cos theta is equal to the x coordinate of that point. Therefore, cos theta is equal to 1. So cos theta is equal to x value, and at the beginning, the x value is 1. The x coordinate is 1. So therefore, the value of cos 0 will be 1. Alright? So, I'm thinking about should I construct the graph differently? All right, give me a second. I'll build a better table for the values. Hold on. All right, so here's what I come up with. All right, so we've got the angle on here. The sine of that particular angle will give you that, and cos of that particular angle will give you that, and tan of that particular angle will give you that. Okay. All right. Cool. So we talk about tan. So tan, remember, is y equal tan theta, tan angle is equal to y over x. We just found the expression. So we know our y coordinate will be 0, our x coordinate will be 1, so tan is just 0 over 1 equal to 0. Yeah, cool. All right, the next obvious one is, let's look at the 12 o'clock position. From the 3 o'clock position, travel to the 12 o'clock position. We know that this is a right angle. So we traveled 90 degrees already. So let's say it's 90 degrees, right? And in radian, we know that 180 is equal to pi, and 90 is just 180 divided by 2. So it would just be pi over 2 radian, right? Now, remember, sine is the y coordinate at that point, all right? And I have already listed here. The y coordinate at this particular point here is 1, yeah? And the x coordinate is 0. So therefore, the sine 90 will give you 1, and cos 90 will give you 0. Yeah? All right, next bit. tan. Now, this is interesting here, right? Very interesting. Now, tan, remember, is y over x. So, while y value is 1, all right, no biggie. And over 0. And here comes trouble. All right, we know once we have something divided by 0, it is troublesome, right? It is troublesome. So normally we go non-defined or not defined. Let's go to not defined. All right, we can't find it. We can't find that value there. It's not on the calculator. It's not on the graph. When we try to graph sine or cosine, it's just not on there. Okay. So, but we will talk about why in another going beyond the expected episode, because that's very interesting. All right. But we'll save that for another episode and focus on unit circle here. All right. So the next one, we'll be talking about our 9 o'clock position. All right, 9 o'clock position. And here we have an x coordinate of -1 and a y coordinate of 0. So at pi, which is 180 degrees, sine would be 0 and cos would be -1, right? And the tan would be 0 over -1. And that would just give you 0. Right? Next one. At here, which is our 6 o'clock position. Right? Which will be our and then which will be 90 degrees more than 180, so that would be 270 degrees. Alright. So we've got an x coordinate of 0 and a y coordinate of -1. So therefore, so at 260 degrees, that would be 3 pi over 2. Now, how I got that is just, I know that pi is 180 and pi over 2 is 180, 90. So 270 is just 90 plus 180, right? So it's just pi over 2 plus pi, and that's 3 pi over 2. That's it. That's how you calculate it. All right, same as before. So if pi is 180, we know that 90 is half of 180, so it's just pi on 2. Yeah? Cool? Alright, I don't know why is this one out here. Okay. So at that we saw that the y coordinate here is -1 and the x coordinate here will be 0. Right? And another funny thing here. So looks like we've seen it before. So this one's -1, 10, right? 10, 270 will be -1 over 0 again. And we get another non-defined. Interesting, but we save it for another videos, okay? And the last but not least, we're coming back as a full circle, right? So we're coming back to the 3 o'clock position here. So again, the point is the same. It's got an x coordinate of 1 and a y coordinate of 0. So at 360 degrees, we should have the same value as 0 degrees. 2 pi. Yeah, since 1 pi is 180, then 360 is just 2 lots of 180, so there's 2 pi. Yeah, makes sense. And we know that, oops, slipping 2. And we know that it has the same coordinate as angle of 0, so we can just copy that. Right, -1 here, so the tan of that is the same as before, so it's 0 over 1 equals 0. Yeah. So these are what we called the 4 angle we just found out, or 5 literally, 0, because 0 and 360 the same, so yeah, okay, let's just call it 5 then. So this 5 angle is called the boundary angle. The boundary angle. Right? Because it's on the edge of the circle. right? It's on the edge of the circle. That's why it's called the boundary angles. So we just found out what they are. We just found out what the what sort of sine value and cos value and tan value at these boundary angles, right? And of course, that's not the end. All right, we can do a bit more with unit circle, but let's save that for the next episode, next video, because I'm getting tired. All right, so we'll take a rest for a bit, and then we'll come back with part 3.